Let's do some more. All right. So we have already started the lesson 4 last time up to the first exercise, right? So let me quickly review what we have done in the exercise 4. So we're making a function called squeeze. Yeah, please, if any question, please raise your hand. Otherwise, please be quiet. All right. So in exercise 1, we talk about a function called squeeze. All right. In between, well, in this function, we're actually deleting whatever character shows up in string 2 from string 1. So you can imagine we're iterate through both of them, right? We iterate through string 1 and compare every single character inside of it with every single character inside that string 2. If we find a match, we get rid of it. Well, by talking about get rid of it, we simply just move our index in that case, right? So for example, here is the solution. You can see, so while in the while loop, we just keep compare the character inside the string 1, right? Every time we finish the loop, we add 1 plus plus, right? That means we move to the next character. And then we will iterate through this second string using the for loop. And then we compare the string from string 1, character from string 1 to character from string 2. If they matches, we say, oh, it works, and we break out this for loop. And if that's the case, we assign the next character to these to the existing character. So it's overriding that character, right? So this is a little bit tricky, and this form is a little bit complicated. But later on you can see it could be done in a much shorter form. But this hopefully more readable, I would say. Yeah, once you reach the end of this string 1, you're adding a new line. Sorry, new terminate character to determine that's the end of the string. All right. So if we test the example of I didn't show the example. All right. So it should be all right. So last week we talked about those double and sign, double or sign, that kind of thing. Those are the logical operator. Those are for if statement, right? If this bigger than that and this smaller than the other number, right? So double and. Here we talk about bitwise logical operator. All right. So this is the most difficult part in this lesson, in today's lesson. That's why I say I need your more attention here. Okay. First of all, it only applies to integer type. All right. And usually actually applies to their binary form. All right. So we're going to see some example later on. For example, okay, we're going to do a bitwise AND operation using this AND sign. All right. And we have a number n, and we end that with 0, 1, 7, 7. Okay, anyone tell me what's this value is? 0, 1, 7, 7. Anyone?
Hexadecimal number.
Yeah, sorry?
Hexadecimal number.
Yeah, octal number. That's the octal number. All right. So I will show you more details later, but the first thing you want to do is you will convert into binary. Right? I mentioned that last time. For every single octal number, you can convert to 3 binary number. Right? Then it becomes much clearer to understand. So let me show you an example. All right. So actually, you know what? I will open an Excel sheet. So we want to convert basically 3 octal number, right? Each of them will become 3 binary number. So the first octal number is 1. That convert to 0, 0, 1. That makes sense? The next one convert to 1, 1, 1. Right? The same apply to the last 7. Okay, that's understandable. So when we doing an AND operation, so here we have an AND operation, and with the N, right? So this is, sorry, this is 0, 0, sorry, 0, 1, 7, 7. I want to add a quotation mark. Okay, and we'll compare it to N, right? Let's say our N is a value. Now I'm only showing you the binary number just to make it easier. So let's say it's 1, 0, 1, 1, 0, 0, 1, 1. Okay, some random number, nine number, all random. Okay. When we do this AND operation, what will happen? So we are using the top one as a mask. What I mean is only when this mask contains 1, I will retain this original value. All right. Otherwise, if it's a 0, those 2 values will be set to 0, regardless what they are. All right. So this is how the masking works. So if this is an AND sign, because say 1 and 1, right, equals to 1, right? 1 and 0 equals to 0, right? So in that sense, so if you keep doing this operation, basically you are repeating whatever number we have just seen from the N string, right? So this part are exactly the same as this part, right? Okay, so in machine language, a lot of time we are using 1 byte for the, because it contains 8 bits inside, right? Inside 8 bits, we have multiple use of those 8 bits. Let's say first 4 bits are for operating one part of your variable, and the remaining 4 is for other purpose. So that means at the one point, we only want to look at the last 4 digits of this byte, versus sometimes we only want the first 4 digits of this thing. So having this mask ready will become very handy. So anytime I say, oh, okay, I have 9 bits, I only want to look at the last 7 of them. So I can create a mask like this, all right? The other example would be, okay, if I'm only care about one last bit of our byte, we'll use a mask as 00001. Okay, I can do this way. So this is why the masking is very important, and also why this bytewise bitewise operation is important. Okay, so let's see another case. So let me just change it to a little bit different case. Just get rid of those information. Now we're having an OR operation instead, not AND anymore. This is OR operation. All right. So in this particular case, what will be the result? So, oh my God, let's say 0 or 1 will be 1, right? 0 or 0 will be 0, 1, 1, 0, 0, 1, 1. All right. All right. So in this particular case, sorry, I should maybe change to yeah, let me change this number, all right? So make it more obvious. Sorry about that. Okay, let's see. The beginning part of it will keep unchanged, right? If it is all 0, whatever information in your N, it will be kept the same, all right? However, for any bits which have the OR operation with 1 here, it will all set to 1, right? So again, this is another way to manipulate a byte. Basically, if we want to set the value on purposely set it to 1, we'll use a mask like this. All right. So anyone knows how to on purposely set a value to 0? Let's say if I want the last 4 bit always be 0, how can I do that?
XOR?
Yeah, XOR. Okay, XOR, right? It flips the value, basically. It's doing the OR operation, then flips the result. Yeah. So great. Okay, so again, this is very important. If you miss this part, the later slides might seem confusing. All right. Any question? No? Good. All right, here, just to show. Yeah, it's very similar to that. Yeah. Actually, to do the two's complement, you need XOR operation. Yeah. All right. So the single operator is called bitewise operator, and the double operator are logical operator, right? So if we're comparing those two cases, if we see both, well, first of all, x is 1, y is 2. Okay, those are the initial value. Both are integer. If we have the single AND sign, that means we are ending using the AND operation between 0, 1 and 1, 0, right? 1, 0 is 2, 0, 1 is 1. That gives us 0, right? Because that's bitewise operation. However, if it's a double AND sign, it will be 1 because both x, y, and y are true. Well, as long as they're not 0, they're considered as true in this case. So true and true give you true, right? That which is 1. All right. Okay, so this is another confusing operation, which is called shift operator. Shift operator basically shifting the bit by, for example, n is which is 2 here by 2 positions here. All right. So what that mean? Go back to our example. So if we have initial value of 0, 0, 0, 1, right? And I'm shifting this number by 2. That means I basically move this number here, right? And I will fill the remaining of them as 0. So it's become this. Okay, so this is done by x by this operation, right? So assume this is the x. All right, basically I'm shifting this thing to the left side by 2 numbers, and I will fill out the space with 0. Okay, so that is how it works. So that means the initial value, which is 1 in decimal, now it become 4 in decimal. No. Right? So yeah. So the same apply to go to the right hand side, right? You're shifting things to the right. To the right hand side, sometimes it's a little bit tricky because in front of your byte, you might have a sign bit, like positive or not negative sign. But we're not going to worry about it. Okay, let's just assume if you're shifting to the right hand side, you also fill everything with 0. All right. All right. So unary operator yields 1's complement of integer. Okay. So this is similar to the 2's complement we just talked about. So basically, it flips every bit into its opposite number. All right. So if we do this way, it's just changing the 1 to 0 and back and forth. All right. Here I was trying to explain that we often want to use this shorter form, all right? Shorter form of the word instead of a longer form if, say, we are having a longer, more bits in our binary. This is to make sure our systems are adaptable between, let's say, 16-bit system versus 32-bit system. All right, so here let's look at some example. First example is we create a function called get bits. All right, it has 3 inputs. The first one is n bit field of x. So that's say let's say just 8 bits, for example. So we want to return the part of the bits inside this and x value. All right. So let me give you some example here. Let's say our x equals to 1101 0110. Right. So we want to get 3 bits from it, starting the position 4. All right. So position will start with. So here is how you decide the position. Sorry, it's a little bit offset, but you can understand. So this is position 0, 1, 2, 3, 4. Right. So this is position 4, means this bits here. Okay. So you want to get from this bit to the right hand side, like 1, 2, 3, 3 bits. You want to get those 3 bits out of it. All right. So let's see how we're going to do it. Using this example first. Yeah, we see how this works in the example, then we look at the code, how we're going to do this. So first of all, we will want to do is we want to shift this bit to the right, so we are remove what we don't. So okay, the idea is, let's say we have Let me just write it down on my Excel sheet. 1, 1, 1, oh, sorry, 0, 1, 0, 1, 1, 0. Right, so this is my 8 bits. What I want is from this position, I want those 3 bits, right? So what I want to do first is I will use the right shift to remove the last 2 bits, which is I don't care, right? Because I only want those 3 bits. So we'll make it become 0, 0, 1, 1, 0. So we'll move it to the right-hand side like this. So that's the shifting operation we just talked about, right? The second operation is I'm going to use is a mask operation, right? I will use an AND, right? This is AND, this is shift, right? So I will use the AND mask. Right, I will do the AND operation, bitewise AND operation, so I can keep the last 3 bits from this string. All right, so this is the process. But first of all, I will understand how many shifts I need to do, right? 2 shifts, that is. So the operation is P minus N plus 1, right? Then I shift it, as I just explained earlier. Then I'm creating a mask, all right? So this is the operation you will use to create a mask which retain the last n bits from your string, right? So this is a very handy way. It might seem awkward, but here is the explanation. I'm not going to dig deeper. But anyway, if you put n equals to 3, this gives you a mask of everything's beginning is 0 and last 3 bits is 1. Again, this is a very, very handy operation. You want to remember that, okay, for your example, for your coding later. And you apply the mask, right? Apply the mask to retain the last 3 bits of the example. All right, so understanding how it works on one example, now let's look at the code together. So the code is very, very straightforward, just one line. All right, so first of all, we'll shift this byte x to the right by 2, right? We just calculated 2 here. And then we do a bitwise operation with a mask we just created. The mask, again, this particular expression will create you a mask which has the last n bits is 1. The remaining are all 0. All right, make sense? All right, again, this has a lot of application, but let's modify it a little bit. Now, when we considering the position P, last time we were counting from right-hand side to the left-hand side, right? We're counting 0, 1, 2, 3 from right to the left. Now we want to do that from left to right instead. Okay, that's the only change of this function. And just to simplify the requirement, you can assume the whole byte is contain 8 bits, not more. Okay, only 8 bits. All right, so that's the only difference in this example. All right, so you can give it a try, see if you can make it work just for practice. I have a template file in our share folder you can use. Yeah, here give you explanation of what I mean by left base counting, right? So instead of counting right to left, it's left to right now. That's it. So we want to keep those 3 bits at the end. All right. So please go ahead and try out this exercise. Yeah, we want to extract this part and we will flip it because how we counted are different now, right? Extract the 0, 0, 0, 1, 1 and flip it into 1, 1, 0 instead. Sorry, please don't be worried about flipping it. Just as long as you get this 0, 1, 1, that's fine, right? Yeah, don't worry about the last part. All right. Any question? So the purpose of this exercise is only just to let you figure out how much position you need to shift, right? So here we're going to figure out the length of our word, right? Assume that's 8, and then use it to calculate the adjusted p. So that's the number counting instead of from left to right, is right to left in now. And then we just following the same formula as last time, like p minus n plus 1 for adjusting the x, shifting to the right side, and then mask to take the last n bits from it. Right, this is a little bit longer version, but you can see the same idea applies. The only thing you need to do is to figure out how to calculate this adjust p in this case. All right, so let's look at another interesting operator in C, which is this plus equal. Right. So if we say I equals to I plus 2, so this is the same as I plus equal to, right? You can do this when you have the same variable on both sides of the equation, right? So that's a very handy operation when you want to increment a value, right? For example, I have an index I for counting the position of character in my string array, right? I want to extract the odd index character from this array. I can then keep adding 2 to my index, right? So this is a little bit simplified version of this operation. So instead of having the add, you can also having other operators here instead, right? So essentially, you can have any operator before the equal sign, and then what that means is you will do this operation between E1 and E2 and assign the value back to E1. So kind of save your effort on typing the E1 for twice. All right. So this is only because such operation is very, very common in C language. So they were trying to save some effort. Here are some examples. Here, this one. Okay, this is tricky because you have 2 variables on the right-hand side. So in that case, you're actually doing that operation on both of them rather than just the first one. All right. Now let's look at some application of this. Let's say we create a function. The purpose of it is to count how many 1 bits is in it. All right. So if it's encounter a 1, it will add 1 to the counter. Right. Counter here is a B. Otherwise, it will just skip it. So in this example, we're using the for loop to iterate through this n byte. So in every iteration, we'll shift this n byte to the right-hand side by 1 position. And then we will, using this bitwise operation, this is a mask, right? Like this mask tells you I only care about the last bit in your string, not anything else. I do this AND operation. That means I only evaluate the last bit in the whole thing. If that's 1, that means here's true. I will add 1 to my counter. Otherwise, I don't do that. All right, n2 that our n, the n is not 0, right? So otherwise, I will keep doing this. So yeah, this is again a very condensed operation because we're using this right shift operation as well as the bitwise operation. But hopefully you can understand. So again, this masking operation will isolate the least significant bit. Okay, least significant bit here means the most right-hand side one. It's called least significant bits. So if we try a number 13, so input is 1101, right? And we do this filter. That gives us only the last bit from this array, which is 1. And because this is 1, it's a true in this if statement, we will increment this b, right? So in this increment statement, we use b++, right? Okay, then we'll keep doing that. The next step, we'll shift this n to the right-hand side by 1 position. It will give you 0, 1, 1, 0, right? Now we're using the mask again to extract the last bit, which is 0 in this case. And then this way doesn't satisfy the if statement, so there's no change to the b value. All right, I'm going to skip the remaining, but then you can see how it actually counts. There are 3 ones in this byte. Yeah, again, 2 operations. One is shift, the other is masking. Okay, so, but we haven't used this operator yet. Before we actually going to try it, here is one benefit of using this. So you can see in this particular example, we have very, very, very complicated left-hand side operation, right? And the only thing we want to do with the value of the left-hand side is we increment by 2. Okay, so that make your code more readable because as long as you see that, you understand, okay, whatever on the left-hand side, I will increment by 2. However, comparing to the scenario, if you put that side to the right part of your equation, it's very, very long. And then sometimes you will get lost of what exactly what I do there, right? And you also do a lot of unnecessary calculation twice, like in that case. But I mean, the other way is you can put every single of those into a temporary variable that may also make it readable. So here, just trying to explain to you, when we're doing this comparison, we're trying to receive a number from the input, and then we put this number into this equation, all right? Okay, so for two's complementary number, we use x and x minus 1 to delete the rightmost 1 bits from x. Okay, this is already give to you. Okay, you can think about how it works, but you can just take it as it is. Now we want to use this operation to create a faster version of the bit count we just see earlier. All right, the bit count again, what we did before is we iterate through every single bit in our x. Then we do the if statement, masking. If that's true, we add. So that's a little bit slow, right? Because you have, if the bit is 32 bits long, you have to do that 32 times. But if we use this operation here, because it's always delete the rightmost 1 bit, right? So every time you run this, you will get rid of 1 bit. and you can count 1 bit from there, right? So let's try to use this way to develop a faster version of the bit count. And hopefully you are using this expression we just showed you, more compact version of the expression. Well, if not, that's fine. Right, you can try use with this example 10110100, right? Hopefully it will give you the output out as 4. So we'll use a while loop, which compare if the x is 0, right? If it's not 0, you will keep doing it. And then you remove one rightmost bit from the extreme using this expression. And every time you do it, you increment the by 1. So that give you the faster version of this bit count. All right, so let's give a try. Again, there's a template file. So this is exercise 4-3. All right. So again, there's only 2 lines of code you need to fill out. First one is decide if x is 0 or not, right? Next one is just to set x to this equation. It's almost like you just put the equal sign in between, that's it. But also you can convert it into a more compact version of it. So this is the more compact version of this. So every time you run it, it will delete the rightmost 1 bit from your byte. And here is the while symbol you can use. Just compare it to 0, because every time you shift to right, until there's nothing, no 1 bit in your byte x, so that means you got 0 in that case. All right, next one. Conditional expression. Okay, often we have a statement. Say we're comparing A with B, and if A is greater than B, we return this A, otherwise we'll return this B, right? So again, there are some condition in between, depends on the condition is true or false, you will have 2 branch. So here is more condensed way of express this equation. So we're comparing E2 and E3. And if one is greater than the other, so not necessarily greater, well, it's like true, right? So yeah, so if E1 is true, we'll go with E2. Otherwise, it will go to E3. Right. So let's try to convert this if statement into this form. So we're evaluating A and B, right? We're comparing A and B. If it's true, we will get result as A. Otherwise, if it's false, we'll get result as B. So this is a condensed form of the if statement we just have. So it's essentially just a maximum A and B, right? Again, so from before this question mark, you will do a condition comparison often. If it's true, you go with the expression before the second expression. Otherwise, we'll go to the third expression. All right. So as mentioned, because here we have two type of data type. One is float, one is integer. In this case, our result will always be double, because we're comparing this floating point. As long as your equation involves float, it will give you the result is double. All right, so let's see this expression in some examples. Here, we're going to print, okay, n elements of array. Every 10 element will become one line with each column separated by one blank. Okay, and each line terminated by a new line symbol. Right. So again, if we're counting the number between 0 to if it's 0 to 9, we'll add a blank after it, after every element. Otherwise, we'll add an end of line symbol to it, right? So in this condition here, we're just trying to determine if we're encountering the 10th element. Right? If we're encountering the 10th element, we will print an end of line. Otherwise, we'll print the blank. Right? So we'll first print this element itself, right? Then we'll decide using this condition here to decide either we want end of line or a blank symbol, one blank symbol. Okay, so let's try out this one. We want to rewrite this lower function. We have write this one before. Now we want to rewrite it into the more condensed form as we just showed you earlier, right? So you have a condition and a question mark and the first expression and a second expression and the third expression afterwards, right? So in that way, we can make this function very, very condensed. All right, please give a try for 1 minute. Sorry, yeah, we have to wrap up. But this should be very straightforward, right? Yeah. Just take a look at this example here, right? Basically, you have the condition before the question marks, then the second and the third expression afterwards, right? Basically, you just rewrite this in this form.